So, yeah, we had a cool thing going yesterday. Although I did not implement it. So, we'll possibly try to implement it today. So, using GPT. So, anyway, the idea is trying to interpret multilayer perceptrons and yeah, like so what we're doing is we're having them implement random Boolean functions, which actually probably isn't like a great idea, because like if you because like some Boolean functions themselves like lend themselves to human interpretability, and other than that, they're just literally random collections of binary strings. But yeah, we're just going to ignore that, so that's fine. And anyway, so we're using the basic like observation, which is that if a right, so like this is like a Boolean function, and like the first row is the input, all zeros, and then 0, 1, and so forth. So like in particular, this function distinguishes these two inputs, and any layer in an MLP that computes this function, that represents this function, has to distinguish those two inputs, because the output has to distinguish them. So what that means is that in the layer, at least one unit has to give a different output for that, on that pair of inputs. And so it's kind of like on some level that that is kind of like an interpretation. It's just like at any layer, it's like what is this unit doing? It's keeping track of these two inputs that have to have different outputs. Right, so anyway, that's how we're going to be constructing these multilayer perceptrons. We're just going to construct them randomly, and at each layer that we're constructing, we keep track of the representations, right? Like every layer produces a new binary representation for a given input. And so we're literally going to do this process where you have like a matrix, and you have like the +1 representations as the rows, and the -1 representations as the columns. And then we're going to somehow select units that what we're going to do is so like this this matrix where we're crossing the accept set of inputs, or I should say representations, versus the reject set of representations. The way the construction process is going to work is we just pick a pair or like an entry in this matrix that is like 0, indicating that that pair has not been separated by the current layer that we're constructing. And then we find a unit that like has to be a linear threshold function that separates that pair, and then we check if any other pairs also happen to be separated. And so we just do that until all the pairs are separated. And then that gives us a new representation. And then we check if in that new representation we have linear separability of the accept inputs from the reject inputs. Because if we do, then we're done. We can just, the final layer can just be an output unit, producing that linear separation. Otherwise, we keep going. So there's kind of like two things. One thing is like it's not clear this will ever end. I think like it. The argument that it would end eventually is that, like by chance, inputs that are receive the same output, I guess like will occasionally be mapped to like the exact same activation, in which case like the total number of points that we're dealing with goes down, and like the smaller number of points you have, the more likely you can linearly separate. But yeah, I mean, there might be at a later time we might try to indicate, or try to come up with some heuristic to like speed the computation, perhaps. Yeah, the other point was in terms of like selecting a unit to add, right? The idea is like you find a distinguished pair that is not currently being distinguished by the layer that you're constructing, and and then you add a unit that distinguishes that pair. It seems like another thing you could do though would be to just train a unit using gradient descent to for all the pairs that are not currently distinguished. Use gradient descent to find a unit that maximally distinguishes the largest number of pairs. And but and then I guess the idea was something like you can then maybe assuming this actually the other issue is like pruning. There might be some pruning involved at some point. But then anyway, the purpose of the thing was you can maybe compare these networks to gradient descent trained networks. it's not clear. It's not clear what the benefit of that would be, but yeah. Or yeah, I might, I might just abandon the whole thing, and yeah, come up with some other idea. But we'll try to implement it first, just to see if it works. Like burn some kilowatt hours. Like electricity. So anyway, the I don't know if I can express all that to ChatGPT. Yeah, I mean, like, I'll just see what happens. A personal webpage. Okay, so like I'm making a Python script that builds a small neural net to compute a Boolean function f. We build it layer by layer. At the current layer, we like we keep track of we keep track of like each layer produces a new representation of the input X at the current layer. We keep track of which prior layer representations are distinguished by F. Are distinguished. Keep track of which part of the representation are distinguished by F. We then add a unit to the current layer to distinguish a pair currently undistinguished by the current layer. You can tell I've had like a lot of caffeine because we do current layer to distinguish a pair currently undistinguished by the current layer. Add units until all pairs are distinguished pairs are separated by at least one unit in the layer. We then check if the this new representation is linearly separable. If not, we add a new layer. Okay, that's fun. That's fun. Oh, it's going slow. Dang. I think I broke the GPUs. It's like caffeinated human brain tissue versus GPUs. Like, who's gonna win? It's still going. It's using sklearn Boolean function. Yeah, I'm not sure this is fine. I'll just see what it does. I don't know why it's using sklearn. It's not cool. Oh, did it break? What's happening? Is it still going? Still going. Keep going, buddy. Program away. Wow, this is going pretty slow. XY make classification. Oh man, it's still going. Jeez. Why is it going so slow though? It's probably at capacity. Might require adaptations. Alright, let's see what it actually said. That was a huge wall of text. Initialize input and output. Create a dataset for the function of. Start with an initial layer. Iteratively add neurons. Oh, it doesn't like units. It prefers neurons. To distinguish pairs of inputs based on their output from F. Yeah, I mean, yeah. This is, yeah. I mean, that's everything I said. Okay, so does this code do that? I don't like that it's importing this, but that's fine. Boolean function x, define your Boolean function f here. Example, XOR. I don't even understand what that's doing. Okay, whatever. It's returning XOR. Alright, next. Add unit. Current representation distinguished pairs. New unit equals NP zeros. Current representation dot shape. Add a unit. For IJ. If current representation I equals current representation J. New unit. Ooh, I have no idea what that's doing. Yeah, I might have to type out more of what I thought it would do. Build neural net. Current representation equals x. While not is linearly separable, current representation y. Distinguished pairs, find distinguished pairs. While distinguished pairs, current representation, add units. Distinguished pairs, find distinguished pairs. There's that append. Classification. Y equals Boolean function. Layers. Yeah. It's linearly separable. Find distinguished pairs. Yeah. Append IJ. Length labels. Distinguished pairs. Okay. I mean, like, I mean, it's like, we want the neural net, I think represented by its weight arrays. So, yeah. Alright. Okay, I'll just try to do it more by hand. Oh my god. Ugh. This is gonna be annoying. Right. Input. Current representations, inputs, x. Okay, right. So, I think first to maintain distinguished pairs. Okay, so we need a function that produces distinguished pairs given a representation. So like inputs, outs, representation, and then yeah, just iterate. I mean, like, inputs is going to be a matrix, so I guess that, generates, starting at I plus 1, 2, shared. I guess that's minus 1. And then, pairs, I guess I'll just be a set of integers. Pairs of integers. So then, like, if I does not equal j d pairs, add ij, return d pairs. You gotta use underscore, guys. Okay, so that's distinguished pairs, so that should work for what I have written. Let's try it out for current rep. So I don't know how to remove from a set. Okay, let's see if that worked. I need to know what the target function was, though. If reshape 1, please. Okay, so this is saying 0 and 2, which is good. 0 and 5, 6, 10, right? That works. That works. Okay, good. Good. And, oh, you know what? We need, like, the neural net representation. Do we? Yeah, I guess. Well, okay. Yes, okay, so like let's pretend we're constructing the first layer. Right, so we're constructing the first layer. Okay, so like first get all of the distinguished pairs for the current representation. Right, and then while I think actually you can just say d pairs, but that's fine. 0. Pick a pair. So pair. How do you randomly select from a Python set? I think you have to turn it into a list. Yeah. I feel like I could ask ChatGPT, but I don't want to use up the usage quota. It's like a rough situation to be in. I mean, whatever, we'll just turn it into a list. Very cool. Very cool. It seems like there should be a better way of doing that. I think you just like take the first one. I guess. Right. Okay, so now we have a pair, and we need to separate them. Which means basically you need to XOR the okay, well, we're just gonna do a weight array. Okay, so like okay, rep 1 is current rep is inputs pair 0, rep 2 as inputs pair 1, whoops, and then the new weight array is gonna be like, I think you just match, so it's gonna be something like 0 if rep 1j equals rep 2j4j in range rep 1 dot shape 0. Else, I think you just make it equal to rep 1 j, right? Because when you dot product, it'll separate, right? Why doesn't it like this? Alright, that goes over there. My bad. Zero. Okay, why doesn't it like this? There you go. Alright. So, okay. So we need a layer, and then you just say like layer dot pound w, and then print layer. This is guaranteed to work. Oh, you know what? It's not guaranteed to work because I'm not. You have to write you have to check if this unit like separates other pairs. There's probably like a better way of doing this. Yeah, okay, so then, okay, so like this is like, first, currently, on layer, undistinguished pair, their inputs, and then like that distinguishes this pair or that pair, and then remove that pair from the check which pairs W distinguishes and remove them from the pairs. Okay, alright. Right. So we can reuse distinguished pairs. Right. But we need to compute the function table for W. Oops. Yeah, W pairs equals distinguished pairs. Distinguished pairs given like current inputs, and then the function table for W, which is rows, one column. Okay, so it's gonna be NP. It's gonna be NP dot like matrix multiply X or inputs with W, and then like you have to reshape it probably to -1, right? And then ow, dang man. So then like, how do you I think you can just say T pairs minus equals W pairs. Is that cool? Probably not. Yeah, okay. Right. Very cool. Yeah. So we should see if that worked. Yeah, we should see if that worked. Yeah. Okay, so to see if that worked, we're going to take these weight arrays. Well, yeah, we need to turn them into, right. Right. Okay, so we're going to turn these into function tables and then just like visually check that it's working. Yeah, just print this. Yeah, except go the other way. think we want to not allow 0, actually. So this needs to be matrix multiply, like greater than or equal to 0. Greater than or equal to 0 dot as type int. Is that cool? That is not cool. And yeah, as type int. So we should do the same thing here. Okay. And that's not good. Also print here. Okay. Why is that not working? Oh, it needs to say L. Right. Yeah. Okay, well, let's just see if that's working. So, okay, so like, you know, so like 0 and 3. Yeah, it'd be a lot better if these match the columns. But anyway, this one distinguishes those two. And that's the only one. Yeah, these columns need to match. Okay, so I'm gonna I need to like convert this to be 1 and 0 and integers. Yeah, I think you can just do the same thing. Yeah, just do greater than equal to 0. Alright. Okay, so like, yeah, let's not print that anymore. Okay, so like this is the function. So for instance, this one handles that guy. Yeah, I mean like this, okay, so like this unit handles all of, like that entire, all of those inputs. But then like this is the target function. The target function distinguishes these two inputs, and this one does not. But like, e.g., this one does. Yeah, and then, okay, and then you're doing like, then you have 1 again. And okay, let's see, which one is distinguishing this guy and this guy? That one. Cool. Also this one. Okay. So I mean, we made progress. This seems to work. I feel like it would be cool to I mean, like, okay, let's just look at the first 5 columns here. So these 2 have to be distinguished from these 3. Like, these 2 units do nothing. This unit distinguishes this one from the other 3, so that takes care of all of those. And then this one from these 2, and then this, so like these 2 units handle the other guy. Yeah. That's very cool. But I feel like, yeah, I feel like what you should do is make a matrix with the units as the rows, and then the columns as the distinguished pairs. Yeah, and then it's just like every column has to sum to 1. But if you get like a column that sums to greater than 1, like you can prune a unit, maybe? So yeah, we could do that, or we could just go to the next layer, because what we successfully implemented is constructing the first layer from the inputs. So like we need to produce the new representation from the layer, which is the columns here. These columns are like what every input is being mapped to. I mean, like in particular, we're going from like 4 dimensions to 6. And also, like, are any of the rows identical? I can't tell. Maybe? It's like hard to tell. Maybe not. Right, because we need to iterate this process. We need to take this new representation. Well, actually, first of all, we need to check if the new representation is linearly separable. Yeah. Okay. Right. Okay. So we'll just do that. Check if new representation is linearly separable. Maybe I should feed all of this into GPT and see what that does, right? Yeah. That'll be really cool. Okay, alright, I'm just gonna feed all of this into GPT and grind away. Grind away, buddy. think this is what I wanted it to do. Holy jeez, man. Okay, what did it do? Yeah. Also, like, I'm still not clear if this is, like, guaranteed. I think, like, if you have a data set that is linearly separable, and, like, you run gradient descent on the data set, is it guaranteed to find the separation? I feel like it is. I was like, yeah, but I don't know. Okay, okay, this is everything I wrote. Good. Okay. Okay, so it builds a linear model. Like, what is the activation function here? Inputs, labels, SGD, labels, do, check accuracy, good lord. Combine original inputs with a new layer representation. Unit. Okay. Right. Is linearly separable. Okay. Can you put this into this function? Yeah, maybe. I'm just gonna do that. Because that's part of that. Okay, this is gonna kill my code. I'm just gonna put it up here, I guess. So this is all just like one. This is all just one function. Right? You can do that, can't you? I don't know. BCE with lot binary classification error. What? Sigmoid. Yeah, whatever. Also, like, what is it? Whatever. Check accuracy. Return. Okay. Right. And then, but the logic is, after you do that, you just do this. I think, what is this doing? Print layer, check if the representation is linearly separable using pointers. Okay, so new representation equals inputs. New unit, new representation, linearly separable new representation. You know, the target function isn't correct anymore. Yeah, I mean, it's not updating the labels. Right. New representation equals inputs. Combine original inputs with the new. No. Why did it do that? That's not what it should do at all. New unit. Right. Okay, so we need to produce a new representation. And the new, like new inputs, new outputs, basically. Right, so New representation. How does it treat inputs? Okay. Okay, so we need to do new representation from the new layer. Yeah. Okay. So new inputs plus yeah. And this whole thing. Inputs equals oh my god, dude. What are you talking about? Right. Oh yeah, let's not do this anymore. Ooh. What? Alright. Yeah, we don't need this. Okay. Cool. Like, also transpose, I guess. Yeah. I think also we want them to be -1 or whatever. So I think we just get rid of that. Get rid of this. Yeah. Oh no. Yeah, no, that wasn't cool. Okay, I think I want to do how do you make this -1, 1? You multiply by 2, subtract 1. Okay. Very cool. Very cool. Right. Let's see. Okay, yeah. Okay, so you can still use TF. I guess, like, I mean, do we want to remove unique rows? And probably. Unique rows equals compare dot unique. I don't know what that gives you. Yeah. So, oh man. What? Oh. There's a U. Well. 0 and 1 are the only unique rows. No, that's not right. You gotta go like a different axis, I guess. I don't know how to use this. What? Right, so go on, I don't know, the first axis, right? Ew. Not cool. What is this doing? Oh. Okay, yeah. Oh god. What do we want to say? Return index true. No, that's not working. Like, four, two, 1, 3, 0. Is that right? It's not working. 6, 5, 3, 1, 4, 0, 2. 0. I can't tell if this is correct or not. Use np.unique to return indices of the matrix. Please. Gonna hit limits. Gonna hit quota. I'm on the free quota. Oh, okay, it always... Oh, I did it right. I didn't even need to do it. Ah, dang, I wasted the quota. That's the worst. Okay, so this is saying like 0, 1, 2, 3, 4, 5. So the first 5 are unique. 6, 3, 4, 5. 0, 1, 2, 3, 4, 5 are unique. And everything else is a copy. What about this one? Ah, dang man. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Yeah, but this one is different. So, why is this not working? Wait, what axis? Oh, am I doing the wrong axis? Yeah. Okay. Right. So I'm thinking like basically they're all unique for that one. Let's see if I can find one where it's small. Small one, please. No, they don't give you small ones. I mean, yeah. Is this true? Like they're all unique? 0, 0, 1, 2, 3. Oh my god, that. And 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 0, 1, 2, 4, 5, 7. That was lucky. 0, 0, 1, 2, 3, 4, 5, 7. So saying this is a repeat, yes. 0, 1, okay. 0, 1, 2, 5, 6, 7. Okay, so like this is a repeat somewhere. Yeah. Okay. Alright, I'm gonna say that works. Good. Good. Okay, great. Right. So then, right. So then we say new inputs equals new inputs selecting the unique rows. And new outputs. It's the same thing. Right. Good. Good. And then check linear separability. Alright. Everything's going well. Oh my god. Target size. Input size. Or this doing this. So why is this not working? Oh god. Why is this not working? Okay. Great. So I don't need this. Great. Okay. Yeah. Make progress.